So again, the question, so this is going to be recorded. Would the shear be on the first meter?
No.
No? Okay. All right. Good. All right. Did you see the formula sheet?
Yes.
Has everybody
Yeah.
seen it? Anyone who didn't see it? Did you print it already?
Yes.
Yes.
Okay.
Yes.
Don't try to access it online while you're taking the exam. Otherwise, it's going to be considered like cheating. The computer system would feel that you're doing something wrong. And in some cases, Proctoria wouldn't let you open the formula sheet. So you need to have it printed. And before you start the exam, you need to bring it out and then do it like this. Here's everything I have, right? You do this. All right, now let's go through this homework and see how close it's going to be from your midterm. So you have given a beam. You have some information about the beam. You have the concrete strength. You have the reinforcing grade, which means Fy is going to be 60. You have center to center span. And then they say effective flange width is going to be 4 feet. So I see this. So my understanding is going to be like a T section was 4 feet. I know that the slab is going to be extended. It's going to be section thick, but I'm going to consider only 4 feet for the flange width. It says the column length is 2 feet on each side. Now, this guy reminds me with the shear slide set. So let me put it on. This could be helpful to understand what is this about. You guys know if I just said the span is 26, it's going to be center to center. It is not going to be the clear span. Just clarify here, clear span versus total span. You guys, you have seen this. So it is true that the shear design itself is not going to be in the exam, but you need to understand this from here. You need to understand that the clear span is going to be from face of column to face of column. The center line to center line span is going to be from the center of support to center of support. Are we clear on this? Yes? No?
Yes.
Okay, good.
Yes.
So when you do the moment diagram, when you do the shear diagram, you do it for the center to center span. But when you do the shear demand, you take it at the distance from face of support of the clear span. So the thing that I'm going to be taking from the shear design is going to be the following item. For this problem here, it says, determine the design uniform load. What's the design uniform load? Is this dead load or live load? Or W ultimate? Which one?
Dead load.
Just dead load? Is it design load?
That'd be off there, isn't it?
This is going to be the ultimate load, correct? Yeah? No?
Yes.
Ultimate load is the same as design load, same as demand. So I'm gonna put this here. I don't know, this is gonna be, okay. So I'm gonna say, this is gonna be what? W ultimate, which is the same as design load, which is the same as ultimate load. How many equations I need to do when it comes to load combinations? I'm gonna say when I have here dead load and live load, because guess what? It says here, dead load including the self weight, which means do not do the self weight. If I say total load including the self weight, do not redo the self weight. It is already included. Unless I say dead load does not include the self weight, in this case, you need to calculate out.
Just the
Live
first
load,
two.
yes, go ahead.
Oh, sorry, just the first two load combinations, typically.
Yeah, exactly. 1.4 dead versus 1.2 dead plus 1.6 live. This is what you need to consider. Where'd you get the dead load and live load from? I'm gonna say from here. It's gonna be given to you. Do you need to do the self weight of the beam in this homework? No, you don't need to. But if I said total dead load excluding the self weight of the concrete beam and the slab, it means that you need to figure out the weight of this concrete element. If I said including, you don't need to. Here's the first item. How about the design moment? Is this simply supported beam or this continuous beam?
Continuous.
How do you know it's continuous?
The diagram
Which diagram?
of the T-beam that has that.
Which diagram? This section of the T-beam?
Yeah.
I'm talking about this beam itself. This beam, it goes from one column to another column, right?
Yeah.
Okay. So when I draw this, I'm not drawing this slab here. I'm drawing this beam. So it's going to be the center line of this beam is going to be along this way, right? This is going to be here one support, and here's the other support, right? This is what you call here simply supported beam. Unless, and then it says here's going to be 26 feet for the span, which means from here to there is going to be 26 feet. Unless I come here, I'm going to say it's going to be continuous beam. And then I'm going to give you here more than one support. It means it's going to be continuous. And then you need to use the Monk diagram. Does it say here's going to be continuous? Is there any referring here or any referencing to the term continuous? Or there's none?
No.
No.
No, so it's going to be simply supported. Do you know the equation for the moment for the simply supported? How much is going to be the maximum moment here? Anyone knows this? Yes?
Are you talking about the WL squared over 8?
Yeah. Okay, good. You're done here with the design moment, which is called also the ultimate moment, which is called the moment demand. How about the location for the critical section for shear and the design shear force? What is that about? I'm gonna bring this here. It's gonna be the only thing that I'm gonna be asking about is gonna be two things from the shear slide set. How would you find out this design shear? You guys know how to do this? This is gonna be structure analysis, pure structure analysis. Which means that you need to go find out the clear span, do the moment diagram, do the shear diagram, find out the moment at the critical section for shear. So you need to indicate where is that critical section of shear and how much is design shear force, which means V sub U. Can you find out the depth? Can someone here tell me the depth when you have positive moment? How much is the depth here?
$19.5.
Okay. Did you do the bar diameter and the tie size and things like this, or you don't need to?
No, it already gives us a 2.5.
Okay, good. All right. So it's gonna be from here to there, right? Okay, good. How about BW and D prime? What is D prime? How much is D prime?
D prime 2 inches?
2.5.
Yeah, it's right there. I mean,
Oh,
this is here. The first problem is gonna be so simple. This for the people. I mean, this is like basic information, basic knowledge. If you cannot read this problem from here, if you cannot read this part, understand the given information, you're not gonna be performing here. So this is gonna be like the basic thing. How about BW? Where's the width of the beam?
18 inches?
18.
4 feet or 18 inch?
18.
18 inch, okay. How about AS? Is it the top or bottom reinforcing?
Is it 3?
Bottom.
Bottom.
The bottom, 3 times A sub
Number
B
9.
for number 9. Okay, how about AS prime?
3 times number 5.
You need to find out the cross-section area for number 5, which is 0.31, right? How about AV? You can say, yes, AV. We discussed this AV in details here. We talked about it enough times. I've been asked a question about it. I repeated a couple of times. You remember this AV? We're going to do here a cut through the ties. So let me do here a cut through the ties. How many ties is the cut through?
3.
3. How about cross-section area for number 3? It's 0.11 times 3. With that, you are going to have your AV. All right, done. Problem number 2. And you got to be careful here, very careful. It says ignore the concrete flange effect. What does it mean by ignore the concrete flange effect? Which means consider your beam to be like this. Don't worry about the flange. Don't consider it in your analysis. Just take this piece and the reinforcing and start to do your business. It says also, and ignore the compression reinforcing, which means just ignore this 3 number 5. They're not there. and then solve the problem. What does it mean? Find out the cracking moment. We have done the cracking moment before many times. Does it mean that you need to do it with the flexure formula or with the force method?
Through the flexure formula.
Why?
We're looking at the behavior of concrete.
So why not the force, the couple method? Which one is easier for you? The flexure formula, right, Sarah? All right, if this faster, just do it, because I did not specify here which method to use. So it's gonna be up to you. If you want to do the force method, you do it, or the couple method, you do it. If you'd like to do the flexure formula, you do it. It's gonna be up to you. I mean, if I'm not specific here on which method, just do the easier method for you. So we're done with this. Yes, depth of the concrete compression block, which is A. Do you know how to do A? Do you know how to do C? Do you know how to do the tensile strain and the tension steel? Reduction factor, FEM N. Compare it with M sub U, and then say if this is good enough or not. Any questions on problem number 2? Problem number 2 means a very simple rectangular section. It has only tensile reinforcing, no compression, no flange, no T section. We'll define this at. Yes, okay, let's go here to the rectangular section, design and analysis. And this is give you the one. Yes, okay, this give you this section here. Just use this formula. You want good examples right here. Rectangular section, compression reinforcing is not used. You can say slide set number 4. So in slide set number 4 is going to cover this guy. This problem. Any questions?
No.
Right, number 3. It says here, consider the concrete flange effect. What does it mean by that? Which means treat this beam now as a T section and don't worry about the compression reinforcing. How is that? It says, consider the concrete flange effect, which means treat this as a T beam and ignore the compression reinforcement. No compression steel here. Don't take it into account. I'm going to say, where should I go? Which slide set is this? I'm going to say, let me look at this slide set. So, okay, yeah, this slide is example 3.1. Exactly. This example 3.1, slide set number 6. So this gonna be here, slide set number 6. You're gonna repeat exactly what you have done here, but it's gonna be exactly the same steps. Cracking moment for a T section, right? And then you do compression block depth. And if folds within the flange width, you're gonna say now it's gonna be a rectangular section. If it's given the flange in the web, you're gonna say now this gonna be a T section, and you just follow this example that we went through already. Yeah, very good solve example. That. Any questions on number 3?
No.
Okay, so it is very clear here. Here it says ignore the T section effect and ignore the compression reinforcement. Here, consider the flange effect, which means treat it as a T section and ignore the compression reinforcing. So great. How about the last one? So okay, last one. It says it is gonna be a rectangular section with compression reinforcement. So actually it's gonna be all numbers gonna be the same. So once you find out D, you find B, and all of these numbers, you can just use them. And AS and AS prime is gonna be the same. So in here, you're gonna treat it as a rectangular section, just like this, right? It's gonna be this rectangular section, no T, and use the top and bottom reinforcement. You need to use both of them. Now, where should I go? Which slide set? Okay, so okay, slide set. I'm looking for this compression reinforcement, rectangular section, not a T section. I'm gonna say, here we go. This gonna be slide set number 7. You have detailed example on it. But in here, I don't really need the cracking moment again, because cracking moment, you're gonna do it once for this rectangular section and once for this T section. Again, your ultimate goal is to find out Vman, but you need to go through the three steps. Any questions? Thanks, Eddie. Yes, any questions? Because I'm done for today.
This is it? That's it?
Yeah.
So is this how our exam is going to look like? Like something like this?
Yeah, something like this. And so in some way you feel that, hey, now I know how the exam is gonna look like, but actually this is everything you have studied so far in this semester. We have studied rectangular section with cracking. I'm gonna say where this is covered. I'm gonna say, yeah, it's gonna be right here. We have studied T section with cracking, and you can use any equation you wanted, which is getting right here. We have done the rectangular section, and then we need to figure out all of these parameters, and here's the rectangular section analysis. Which slide set is this? You can say slide set 4. Okay. We have also done this T section with no compression reinforcement. This gives you slide 6. We have done also this in slide set number 7. So we covered here everything you have studied in terms of flexure, and we didn't touch the shear yet. Now, it is your chance to ask me before the exam. Now you have a document in you have this homework that you need to practice. Be sure that you do it a couple of times. You understand every single word that I put there.
Will you be posting this solution after the due date?
After this due date? No, because you have the solution right here. If you like to see the solution, it's gonna be right here in this slide sets. Let me put this again, okay. This section here about the shear, I'm gonna say slide set 8. So I'm gonna put here slide set 8. Let me put it here. You have the method. You know exactly how to do this. How about this rectangular section? You can say rectangular section. Where this is at? First, it's gonna be uncracked, which is slide set 2. So you say here slide sets 2 and what? Can someone help me for the rectangular section? And 4. Am I correct?
Yes.
Yes. Okay. How about this? I'm gonna say this is gonna be for the flange effect. Which slide set is this?
3.
6.
6.
It's gonna be 6, right? Each one of the slides sets, you're gonna see detailed analysis and good example that you just need to follow. You need to study it very well, try here, and also you have the homework. How about this one here?
7.
Excellent. So done. I mean, you have this now recorded, right? So you can just open this and look at the slide set, study it, you finish this. This is correct. The cracking moment is the same, yeah. 7.5 square root of the prime c. Uncracked section. this is the way that you do it. Do we have a homework? Yeah, we have a homework for it. Do I really need to use this method? I'm gonna say, no, you don't have to. If you have this method here, it's gonna help you out to do it for quick. Why not? So we had for rectangular section, we have also for a T section. Here's the rectangular section. If you want for the first example that you guys have taken, here's that. How long this is gonna take you?
Like an hour.
Okay. Critical section for shear. Let's say that you have here, based on this, it says center to center spans 22 feet. How big is the column size? Do you guys know the column size in this case? It says here 2 feet. How do I know it's going to be 2 feet? Because from the center of the support, I'm going to have a foot right and a foot to the left. So in here, it says the same thing. It says center to center span 26 feet, and the column length is going to be 2 feet on each side. Let me look at this. So in this case, this is going to be 26. It's going to be the same 2 feet and 2 feet. So in our example, or in our homework, if I may write here, so I'm going to say L center to center is 26 feet. And L clear is going to be equal to 26 feet minus 2 feet. Why didn't it say minus 4 feet? Can someone help me with this?
Is it because it's centered?
Yeah, because this is going to be right in the center. This beam is centered on the column. So when you do the moment diagram, it's going to be based off the clear span. The center to center span, excuse me. When you do the shear, it's going to be based on the clear span. And then you're going to be also going d distance away from face of support. So if this is going to be face of support, you need to go d distance to find out the shear. In your case here, d is going to be equal to, it says here 22 minus 2, it's going to be 20, 19 and a half. So it's going to be 19 and a half. So in our case here, you're going to be going here at d distance away from face of support. And this distance is going to be equal to 19 and a half inch. You need to put it also in feet. If you like to do the shear, it's going to be easier if you just do everything here in feet. So this little distance this is going to be 19 and a half inch. After that, you need to find out the shear at this location. So critical section for shear, again, just try to memorize it this way, is going to be at d distance away from face of support. So I'm going to say critical section for shear at d distance from face of support. All right. Any discussion here about minimum steel? Did you guys anything about minimum shear steel? Minimum flexure steel? Is it here? Did you guys see it? Yes, no?
No?
Okay. So does mean it's giving the exam or it's not?
No, it won't be.
Okay, all right, great. Okay. Just want to be sure that we're on the same page.
So Professor, whatever is not on the formula sheet won't be on the exam?
Well, it depends. For example, let me open the formula sheet. If you're talking about equations, you're right. But if you're talking about ideas, no.
No, yeah, just equation.
Yeah, just equation. Yes, Eddie, it is my job. Okay. So you guys see here the minimum reinforcement for the flexure members, right? So you have it. So if you like to use it, if you have it in the exam, go ahead and use it. But I didn't mention it in this practice homework. It is not there. So it's gonna be up to you. You'd like to study it anyways? Yeah, why not? How would you study this? I mean, it's so simple. You have one simple equation here. Here's the second. 3 square root of prime c, bw times z divided by f sub y. What do you want to study about this? Just take the values and try this AS minimum. Just in case. So you have all the information you need in this sheet, besides your understanding. Yes, if you use any of these equations, everything should be in P sign. Unless you know what you're doing and you're very careful, and then in this case you can do K sign. So F prime C, Fy is gonna be all in P sign. Now question, just curiosity here. Within this exercise, you see anything that we didn't cover so far in this semester, in the 408? Anything that we didn't cover yet?
We covered everything.
Okay. Do you see anything that we did not cover? So, I mean, yeah, okay. Have we covered anything that's not in here? This is correct. For the minimum, you need to do both equations and then you take the greater of the two or the largest of the two. We don't really need the conceptual questions in this midterm. They're not gonna be there any. Okay, AV is recorded in the previous lecture, and just so you know what you need to do, let's say here's one example that you have number 4 ties, you cut a section, and then you see how many bars that you're cutting through. In this case, you're cutting through 2 rebars. For number 4, the cross-section area is, let me check it out, is gonna be 0.2 square inch. So I have it right here. Here it is, number 4 is gonna be 0.2. Don't work with this. This is gonna be just the diameter, right? This is gonna be 0.2. So in this case, I have here 2 rebars times 0.2 is gonna be 0.4 square inch. I say, okay, give me another example. I say, okay, let's do this. I'm gonna be cutting through this section. How many rebars do I cut through? I need your help.
3.
3, all right. What's the cross-section area for number 3 rebar? 0.11. You see here, AV equals 3 times 0. All right. Yeah, I guess I'm done here. And if anyone has a question, maybe you can see me at the office hour. Otherwise, we should be fine. You guys have a good night.
Thank you.
Bye-bye. All right, good night.
Professor.
All right, good night. Goodbye.